Hi, I'm Michael Courtney. In this video, Rosalba Courtney will be looking at assessing carbon dioxide levels using capnometry, what they do, what they're measuring, and looking at capnograph waveforms and how to read them. This is taken from her pre-recorded lecture within the Integrative Breathing Therapy certification training. Enjoy.
To assess hyperventilation, you really should measure it. And in this section, we're going to be talking about some different equipment. So one of the ways to measure carbon dioxide is transcutaneous measurement, which means that you're actually measuring CO2 through the skin. And there is equipment out there that will tell you what the CO2 level in arterial blood is from skin measures. This equipment's quite expensive. So I've tried it, but I have never had it in my clinic. It's been used in some of the research, but being criticized because there's a bit of a delay. There's like a 2-minute delay. So you're not getting real-time measures of CO2, you're getting a slight delay. What most people do is measure exhaled CO2. So it's called end-tidal CO2. You're measuring the proportion of carbon dioxide or the partial pressure of carbon dioxide measured in millimeters of mercury in exhaled air. So it's called end-tidal CO2 because it's actually giving you the measure at the end of the exhaled breath, which means that if someone breathes more slowly and makes a longer exhalation, there's an increased sampling time. And it's one of the reasons that slow breathing sometimes looks like it's giving you higher CO2 than is actually going on in the body. You've just got this increased sampling time with a longer, slower exhalation. So what is end-tidal CO2 telling you about? It's telling you about CO2 in the body. So the CO2 in the body is determined by a person's metabolism. The CO2 in the exhaled air and the amount that's being removed from the body is determined by the rate of diffusion. It's also determined by perfusion, the blood flow, being able to pick up CO2 in the tissues, carry it to the lungs, and then you need good blood flow at the lungs for the CO2 to be able to cross over and be exhaled, and also about ventilation. So ventilation, as we talked about in the last lecture, is a major important determinant of CO2. Now we're going to talk about the capnograph waveforms. Different capnometers will show you the capnograph form image to different extents, but it is a good idea to be able to see the waveform. I'm going to show you a video in a moment that explains them quite well. These are just some screenshots from that video. So the normal waveform has this, it's sometimes called the Rock of Gibraltar. It's sort of a flat top that slightly angles up. And the size of that wave can be high or low. High means that you've got higher levels of CO2, and the top here is the exhale, the bottom is the inhale. And then when the wave itself is smaller, that means you've got a lower level of CO2. And then you have times when the wave is actually increased, when you have a higher level of CO2. And you'll get these different shapes, the shark fin shape indicating obstruction. Sometimes you'll just see a kind of a slightly pointy, you won't see this flat top. That's quite common when someone's breathing a bit more quickly. And in the video they explain about the leak, and you have this thing, the curare cleft, and sometimes I actually see this with my patients. You see a little dip or even multiple dips at the end of the exhale like that, which is just showing you that something's going on with the diaphragm. And this is what I was referring to before. So very often when you get people to slow their breath, you will see this lovely Rock of Gibraltar shape. But when people are breathing very quickly, you'll have more of this sort of look around the capnograph.